Okay, we are live on YouTube now, which is scary. CSCI 240-10/18. No, because I'm trying to fix his Android Studio, so thank you, though. Okay. Yes, did you find it? Oh, Jesus. How do I change that? Sorry, apparently I'm restricted on my video, so trying to find the setting to here. I'll put it up here. You can all look at it and tell me where I'm missing it. He tried to view it and it said it's restricted. It might be because I created it with my school account, and maybe by default. All right, I'm trying it again under a different account. I'm naming it CSCI 240-10/18 number 2. I haven't yet created it, so what's that? Yeah, I mean, those plates, because they're pretty thin. Stream now. Gosh. All right, I apologize that this is taking so long. Privacy, public. I'm going to just keep going because I think I can probably change it later. Oh, that's creepy. I played the live stream through mine and I could hear it. They're the public stream, so I don't know. All right, so things I want to talk about today. I've got these very thorough PowerPoint slides with, see how many slides there are? Because I got some other stuff I want to talk about. So, project part 1 questions. We're delaying now till Friday at midnight. I have gotten some good questions. I helped some people out with their design. So if you have questions, email me, and I'll get you started on the right track. So Yes. Yes. No. I have no, I don't have Charter. I have CenturyLink. I'm good. Yeah. Okay. Perfect. These are the crow's foot symbols. I don't know why I have that slide in here, so I don't even know why I opened the slideshow because what I was planning on doing does not involve slides. So, I'm sure you all have seen that your exams are graded, right? So let's talk about that. So the exams were not too bad. There was two people that had an 86 out of 100. I took the 86 out of 100 and I added 14. Those people got 100. So I added 14 to everybody's score, which worked out. It was something like 4 A's, 5 B's, 5 C's. Like it balanced out about how I wanted it. So I want to look through a few of the questions on the exam just to review. Now, that also lined up with Moodle will tell me what questions are not valid indicators, either because they're too easy or too hard. Some of them were too easy. Like it says, this is not a good indicator of what somebody knows, because if everybody gets it right, it's not a discriminating question as far as knowledge. So it identified about that many points worth of questions that were too easy or too hard. I mean, I know that exam was difficult, but it was pretty much right off the study guide, right? As far as the questions, just we covered a lot of material, so what do you're not going to get it all. So, um, but let's look at some of these. So we have internet, but it's not the 1 gigabit connection we get through Charter now. So it's the 100 megabits per second we get from Blackfoot, because we could only get 100 from each for the whole entire school district, thousands of computers. So they could get 100 from each. So they got it from each. And then a load balancing device splits the traffic between the two. But we renegotiated and got 1 gigabit now from one of them. So, well, we're going to try to get into Moodle. Okay, there we go. Okay, I'm going to move this for a second because I want to load the exam, but I don't want to accidentally like flash everybody's score up there. So the vision thing, yeah. See, I usually have my face on there, or sometimes I have a creepy clown, or wow, our internet is slow. Can you do what? No, because I don't think they have the administrative software installed on there, but yeah, probably. Okay, that's not the view I want because that shows everybody's scores. Okay, this is the view I wanted. So, the average score was 70 before I added the 14 points. The median was 67, so raise that up. I was pretty generous, I guess, on that. So they have some pretty crazy, whatever kurtosis is, coefficient of internal consistency. So they go crazy on these, but I wanted to just go through. Wait, I just accidentally pushed a button on here, and I don't know which one's muted or not. You think it's on if the light's blue, or oh, I think that's something else. I don't know. See if I can hear myself in my own live stream. Yes. See if I can hear myself. I just heard. So, all right. So this has every question, which is kind of nice because we can see the responses. Every cell in a relation can hold only a single value. Um, that's true. It's not a relation if it has more than one value. Personal databases such as Microsoft Access create a clear distinction between. It's basically like the application and the database itself. The answer is false. They don't create a clear distinction. It kind of blurs those all together. All those four components that later I asked you to answer that only about half of you had any idea what I was talking about. So we'll see that in a second. There should be answers to all these if you view your exam in Moodle, so you can see what the correct answers were. This question, it's red because it was either too easy or too hard. Discriminative efficiency, that these are what determine is it too easy or too hard. The basic idea of a join is to combine the contents of two or more relations into a new relation. That's true. We have two separate tables. We want to run a query to bring data from both of those together. I think hopefully a lot of people got it right. Which of these stats says? I got to remember how I interpret these. Intended weight, random guess, of course. Facility. $13 got it correct. Yeah. It just, these are because these came out of like some weird test bank. So like there was thousands of questions that I could choose from. So since surrogate keys are used to uniquely identify rows, their values are normally displayed prominently on all reports. That's false. Surrogate keys are ones that we essentially make up, which this same question came up in a different version in a short answer, right? Like to discuss what a surrogate key was. So this is the number correct. So these were too easy. I think that's what this is. No, that can't be right because these are 100%. Too many stats, right? 13 again on that one. So I don't know where the percents, how exactly that works. In the relational model, each row contains data that represents an attribute of the entity. That's true. Primary key is used to identify unique rows in a relation and to represent rows in relationships. That's also true because foreign keys use the primary key, right? When it's in another table, like when you link two tables together, you're using the primary key in one table as the foreign key in another. So this one, Yeah, why is that one red? I don't know. True, false are not the best discriminators anyway because they're 50-50. I don't want to go through every one of these. Let's pick up the ones that are red because this will take forever. Normalization is the process of removing all functional dependencies from a relation. That's false. You're still got it. You're always are going to have at least one because the primary key is always determines everything else, right? You may be modifying or changing and removing some of them, but you're not removing all of them, which I mean I could see that being pretty tricky. So 10 said false, so that was 6 said true. In a relational database stores data in the form of tables. I hope this is because, whoops, too many people got it right that it's red. Yeah. I tried to kind of ignore the reds for too many people got it right and count up the reds for too many people got it wrong. Like the order of columns returned by an SQL statement is determined by the order by clause. The order by clause is the answer on that one. And only 2 people got that right. Wait, which one? Oh, the order of columns. I read it as the rows. The order of the columns is yeah. I misread it. So some of you probably did the same thing as I just did. The the rows are by order by. The columns are how we list them. Doesn't matter what order they are in the database. In our select statement, they'll come back in the order we list them in our select. Yeah. So order they are listed in following where. In where we don't list any columns that we're returning. So a couple of you got tricked, 3 of you, by it being rows. Not tricked, but I mean, you just misread it. A table that meets the requirement of a relation is said to be in which normal form? It's first normal form. All it has to do to be a relation is have atomic values, meaning it doesn't have multiple values per column. So 7, half, a little less than half. Boyce-Codd normal form, that means you've gone through everything. You know, the whatever that little saying was, right? So being a relation means you've gone really through no normalization other than checking that your values are atomic. Oh, my gear. Which would be used to remove only the data from a table student while leaving the table structure intact? Yeah. Delete from that one's my personal one. It's very worn in. um, delete from student is the answer. Um, yeah, truncate could work, but that's not one of the choices, right? Yeah, you could use a truncate command. Delete from student because you're doing no where clause, so it's just going to delete everything. If you do a drop, that's going to kill the whole table. Now, the key thing there was leaving the table intact. So only 5 of you got that one right. So select star from student, then drop. No, that's non-existent syntax. That won't do it. That'll error. That doesn't exist. The existing values of data can be removed from a table using the SQL delete. So, I mean, this was kind of, if you missed one, you might have missed the other, right? Drop will remove the table. You know, truncate. Is this what you put? Truncate? For this question number, because you said truncate on the last one. One person did truncate, one person did truncate, spell it wrong. So, it's not really question 79. What question was it? 46, truncate. I think I would give that to you. I gave you I hand regraded all the fill in the blanks. So the fill in the blanks kind of killed you guys. So Microsoft Access is considered to be a personal database. What? Oh, we're past the fill in the blanks. What is a personal database? So something about it's meant to be used by a small number of people. I mean, this actually, I think these are non-discriminating because you did too good on them. The short answers you did were generally pretty good. The fill in the blank were a little iffy. Explain the concept of a foreign key. So that's where you have a primary key stored in another table. You use it to link the data together. Distinguish between the primary key and a candidate key. This one might be, does it say what the score was? You had the best answer. The primary key is just any candidate key you chose to be the primary key. A lot of you had some convoluted explanation of the difference. There really isn't a difference. Any candidate key could become the primary key. It's what the developer chose to be the primary key. Yeah, pretty much, yeah, and that's what I was looking for. Concept of a surrogate key. This was not great either. A surrogate key is where you choose something to be the key. Usually it's an ID, an auto incrementing number is what it almost always is. So again, there was some interesting answers of you're trying to get something out, but but overall, this was not bad. It's a good start. We covered a lot of material. And the SQL stuff in here, there was a lot of SQL. We haven't had a ton of practice yet. That's coming, So I was testing you kind of on like basically just book knowledge from getting it from the book and watching the PowerPoints and stuff. But until you've had time to practice it a lot, like you'll know what a delete statement is once you write a bunch of them. So homework 3, I also graded. Did not grade homework 4 yet. Homework 3, I posted the solutions. So, and I gave you a lot of feedback on your answers of what you should be. This was pretty good. Identifying functional dependencies is still hard for us. So, like this one on C, almost nobody got it right. Identifying these two functional dependencies. So, student name or student number can be used to determine the student name and the major. So if I have a number, I know the name and I know the major, but do I know the sibling? No. Some of you tried to include sibling in there, but there's three of these. So knowing one doesn't really tell you the sibling. The second one was the even trickier one. The combination of student number and sibling name can give us the student name and the major. So having this and this, I can identify these. That one's very tricky. So, and I didn't hammer you if you were in the ballpark. I was looking. Yeah, right. So yours was, I think I said it's not a relation, right? Because they're separated by commas. Yeah, that would be the first initial way to do it. Yeah, but it wouldn't meet the definition of a relation because you have non-atomic values, basically. Break. Almost all of you got this though. How you broke it apart into these two relations. I'd say 85% of you got that right. So even if you didn't identify these, you saw what you needed to do to fix the problem, which is kind of the key. Hello. Oh, you want a gear? Yeah. Um, can you guys bring those orange ones up here? Because I want to let him pick between those. They're playing with them. So these are my Missoula College students. Yeah, the internet's down. That's a 6 gear. That's a 5 gear. That's an 8 gear. Whichever one you want. Fives are good. I like the fives. All right. See ya. Yep. See you tomorrow. Oh, this was going to be the first day I didn't sell a gear, so I'm not skunked. Yeah. Hour and 40 minutes after school is over, even. I have no idea. He must have just. I'm never usually here at this time, so. So, the rest of this key goes through how you would break that up to get to those two tables and normalize it. I mean, none of you did this, but if you want to see the process, it's here. The next question, functional dependence, which of the following are true? Project ID does not determine employee name. There's multiple project names with different employee names. Project ID does not, for the same reason, doesn't determine salary, right? So that doesn't work. But if project ID and employee name are together, that can determine employee salary if employee name determines employee salary. So this was kind of a tricky one, though most of you got it. Employee name determines employee salary. Yes. Salary determines project ID. No. Salary does not determine project ID. Salary does not determine project ID and project name together. What's the primary key? Almost none of you got it. It's the employee name and the project ID. It can't just be the project ID. There's duplicates in here, so that can't be a primary key. It can't be the employee name because there's duplicates. But if you do both of them together as a composite key, that will work. If I tell you Eric Parks project ID 200C, you can go straight to that row. There's only going to be one of those. So that was a little tricky. Are all the non-key attributes dependent on the primary key? No. You can determine salary from the employee name. That's dependent. That's one of those partial dependencies. It's not dependent on the entire key. This is in first normal form. Anomalies, you guys did good. These you did pretty good. You needed to break it down into something like this. Assignment, project, something like that has the project ID and the employee name, and then a salary table that has the employee name and the salary. Several of you correctly said employee name is a stupid key. We should really have like an employee ID here. Because this is assuming two people will never have the name, right? This is poorly designed. So some of you added that in, which is great. That makes perfect sense. Any questions about homework 3? I gave you feedback in Moodle. If you didn't, is it pretty obvious that it's there when you go in there? Okay. Oh man, I just left Moodle completely. I was like, man, time is sure moving slow here because I've got this little strip of screen stuck on my monitor because I've got a narrower resolution than the monitor, and I keep looking at 421, like because it's frozen there, it's not moving. Noir, is that you on YouTube? Okay. I just got an email that you subscribed, so. All right. Homework 4, I probably will have that graded by next week, realistically. I doubt I'll have time tomorrow to get it done, so. Yeah, or internet access. I hope it's back by Thursday. Homework 5, which I have not posted yet, but I went through this the other day. I'm going to post it. I'm just going to adjust now that we're tweaking the project. I'll probably adjust the length. This is from chapter 5. I'm going to post it so if you want to be ahead of the game. And it's going to be chapter 5 is about normalization. It's going to be going from our ER diagrams to our table structure. So, and then there's going to be more practice on it for working with database queries. So we need more practice with that. So I'll post this by Thursday for sure. I had set the due date as October 30th, which would be, I'm trying to pop up the calendar on that frozen strip, which would be, it's Sunday the 30th. I'll probably stick to that because I think that'll be plenty of time. Project will be due Friday, homework 5, the 30th. Then I will also post at the same time as I post homework 5, project part 2, which I tentatively had as Wednesday, November 2nd. So a few days after the homework. I'm probably will push this back to Friday, November 4th. Project part 2, and I'll go again over it more on Thursday, but just to kind of give you a heads up, thinking ahead, you're going to take your ER diagram and you're going to map it into a relational schema. That means you're going to translate it from an ER diagram to what your table structure will be. You'll do your primary keys and your foreign keys and all that. Not in the tool still, like in Word or something. Remember how earlier we did tables in Word and you just kind of laid them out, or in Excel? You'll be doing that. Then you'll be normalizing. You'll identify the functional dependencies, or at least, as it says here, the critical functional dependencies. And then you're going to list out some operations that you'll need to perform against your database. This will culminate with the design crit, which means you're going to present your design to everyone in class, and we're going to give feedback on it. I was going to say that's what she said, but so last couple things, we'll get out of here a little. I was going to take you through a model of creating an ER diagram for a simple idea. So this will help you for your project to kind of verify, are you doing what you need to do? So we'll do this for, I don't know, probably 20 minutes, and we'll get out a little early. So let me pull up the file. Where did I put that? Oh, yeah. I just now got it. You shared a lucid chart. It's lucid chart. It's blue on my screen. This projector sucks. You could use like pet doctor. You you could use a table for your. Is this for your clients or something like the doctors that work there? Yeah, it looks pretty good. You're not going to make it to the 10 tables with that because you don't have any many to many relationships. So you might think if there's one or two more, you can kind of stretch that out as. Let me think about it. Yeah, that would work. No, that'd be a separate table. Yeah. Yeah, that would work. So that gives you kind of an idea, right? Like he's in the ballpark there. Somewhere I have a document. I just got to find it. It'll be all right. I'll suggest other things you could do. If you get to 6 or 7 in that range, you're fine. If you get to 6 or 7, you're probably good. And then I'll look at it and be like, oh, maybe add this, like, yeah, right. So no, it doesn't have to have any mini to mini. It's just if you have mini to mini, 2 becomes 3 when you go to the next step. So that's just, yeah, that's where you might have 6 relations, but if they're related as many to many, that might be 10 or more once you turn them into tables. Because we haven't got there yet, but you'll see any many to many relationships, you create another table in between those. So it blows up pretty quick. I had people that worked hard last year to get 10, and then they were all many to many, and then they had way, way too many, and I had to tell them, like, you don't need that many. Yeah, so now last year we kind of built this up as a class, but I'm just going to tell you what's in here so we can go faster. This is sort of a pseudo database of like what we started with at my software company. So my software company was doing employee scheduling. So you have to store information about businesses. You have to store information about skills or positions, like what can people work as within each individual business. So bartender, it's really positions. Skills, it's positions, really. Uh, Departments. So each business is going to have some departments. Might be the kitchen, it might be the front. What do they call it in a restaurant? The front end or something? Front of the house, back of the house. Yeah. So they like to divide them into departments so that a different manager can kind of manage employees in each because different people schedule. Um, and then of course you're going to have employee information. So all the employees need to have some number, a name, part-time, full-time. What departments do they work in? What positions? What's their pay rate? What's their password? Because they have to log in. A couple of you have asked me about if you want to make a site that people can log into. Perfect example for the pet doctor. You would need user table to store user accounts so people could log into it. If when we get to building the website, that's going to be the part 3 and 4 of your project. If you want to build an authentication system where people can log into, somewhere you have to store usernames and passwords, whether as part of your address table or could be a totally different table. So, and then of course you need to store people's schedules. So in our system, these were called events, and there was 4 types of events. I guess there eventually was 5. Shifts, that means you work. You like are scheduled to work. Unavailable, you can't work. Like you have school at that time. Vacation, you're on a vacation. And then a cover. A cover means someone else has covered a shift that you were scheduled for. So I have a shift. I make a cover request. Can anyone in here pick it up? If they say yes and it gets approved, my original shift becomes a cover. Oh, they same kind of thing. Yeah. Because we want to track, we don't want to, when a shift gets moved, lose who was originally scheduled for it. Because businesses want to track how often is an employee trying to get people to cover for them. You know, like if it's half the time, maybe something's wrong with their schedule, or maybe they're a bad employee, right? Like, okay, more layers. Ours, you could just do it, and then it would send out a text message to everyone that could pick it up, and then they would say yes or I would pick it up. Then the manager gets a text message saying yes, I'll approve that transfer, and it all happens through text or through the website. The manager gets to pick, and it tells you when they get to pick how many hours the person picking it up will have if they pick it up. So then you know if they're going to go into overtime. You might pick someone who's not going to go into overtime. I mean, our software is a lot of it was saving, or is. I mean, I don't work there, but anymore, but it still exists. Saving the businesses money by helping them manage their schedule to avoid overtime. What I'm sure is happening now, they have these crazy rules about salaried employees have to make at least $42,000 a year. Um, people are gonna want to use that software now to start tracking salaried people's hours in order. I mean, it's probably great. They're probably pumped over there at the company, like, because this will normally salaried people never track their hours. Now they're gonna have to, unless they're paying them more than 42,000, which a lot of people aren't. So, um, having that ability to track hours. And then also what was coming in right when I was finishing at the business was Affordable Care Act. If you had got over 32 hours, you have to have health insurance. So businesses were actively wanting to monitor hours so that they don't let people get over that, right? Right. So, because it's based on average, right? Your average number of hours in the last year. So, you might want to know if people are picking up shifts trying to get over that average. You don't give them those shifts. And actually, we had started implementing alerts based not just on 40 hours because of that. So, I always felt torn because you're writing a software to help the business. Um, in some ways, not take advantage of their employees, I guess, but it's for Affordable Care Act. If you work more than 32 hours on average in a year, the business has to give you health insurance unless they're like a certain size. If they're too super small, you don't have to, or yeah, they want to keep you under so they don't have to pay for your health insurance. It was a big deal for Walmart because they have thousands upon thousands of employees, and they actively want to keep as many of them as they can under that 32-hour threshold. Yeah, everybody does it now. So this was new 4 years ago when I was finishing at the software company. It was when it was coming out. So yep. My brother works at a nonprofit. They all make less than 42,000 and they're all salaried. Now they have to start tracking everybody's hours that works there, and they have to get paid overtime if they go over 40 hours even though they're salaried. Yeah. They keep you way below so you don't have any chance of inching towards that 32 hours. Yep, everybody does it. Any big corporations that are actively managing that. Yeah, now it's the smaller ones, and Orbital Shift enabled smaller businesses to do the things because they don't have the manpower or the software resources, but they can pay $20 or $30 a month to Orbital Shift, and it enables them to do all those things. Now, we did have lots of cases where it benefited the employees too, but I mean, in general, yeah, right. Everything's paid, yeah. Yeah, right. My wife worked at Target at one point, and they had the same thing. She was hired as holiday, and then she stayed, but they like suppressed her hours so low. Um, so I went through completely creating this last year. I'm just going to show you what we did because you'll get the gist. We start with a business table, has a business ID, has a business name, has an address, and a phone. That's once you identify what some of the things you need to store, the basic level of creating your diagrams pretty simple. It's the relationships that are the more complicated part. So a business can have more than one location. This was something we didn't have when I very first designed our software until we had clients and they're like, wait a second, there's two Sean Kellys. There used to be back in the day. Now there's not, but we want to manage these separate, of course. And it's like, oh yeah, duh. So a business has locations. Now here we don't show the foreign keys. What's going to happen in the end is a location ID is going to store the business ID. But ER diagrams do not show foreign keys. They only show relationships. So if you put foreign keys in your ER diagram, you're jumping ahead a level. We don't need them yet. That'll come. We're going to learn a whole process how you take this and make tables, and there's going to be an algorithm you step through. So here we just say a business has mandatory to many locations. They have to have one. Doesn't make sense for a business not to have any, at least in terms of a scheduling software. A location has one and only one business, unless it's like a location that has multiple businesses in it. But that would be tied to a separate business, right? Like it just wouldn't come out that way. So a location then in turn has positions. It has one or more positions. If you don't have positions, no one can work. So that makes no sense. A position is in one and only one location. So this system is not set up so you make bartender and you tie that to 5 different businesses. The positions aren't tied to the system, they're tied to the location. A location says, okay, I'm the manager of this location. These are the positions I need. And then in turn, positions have employees, but people work more than one position, right? I'm a bartender and I'm a front end hostess or host. That happens all the time because they classify them in different positions because they pay them different rates depending what position they're working in. So a lot of you've worked in restaurants, right? That happens. A lot of these things were driven by bars and restaurants. Their staffing needs are more complicated than almost any other business in how they staff. And the flexibility needed in staffing, because you don't know how many people are going to show up. And it's different. Walmart is probably a little more static, but still seasonally it varies. Um, okay. Okay. Right. Kind of like if you go tour Microsoft in Redmond, I went there. My wife's cousin works there. And a lot of the people that work at Microsoft don't really work for Microsoft. They work for other companies that Microsoft contracts, and then they pay them. She made like 30,000, and if you worked for Microsoft, you made like 60 or 70. This was like 10 or 12 years ago, but they contract it all out, and yeah, so it's I don't know. These are the reasons why I hated business and I fled to academics, because I just feel like everyone's trying to screw everybody nonstop. That's pretty much all I experienced in yeah, right. So this is our first many to many relationship. A position has one to many employees. Now, you could make an argument that this is optional, right? Because what about when you first create it? See, an employee though can have one to many positions. So this is many to many. Now, what's going to happen, and we'll see this next week, when you have a many to many relationship and you go to make tables, you'll make a table for this, you'll make a table for this, you'll make a third table that includes the primary key from this one and the primary key from this one. So you'll have a third table called employee positions. It'll have the employee ID and the position ID. That's how you map someone to more than one. So we'll see that next week. Now, where this database, and I'm just going to throw out department in this to simplify it, where this database gets a little interesting is how do we tie an event to an employee? Remember how we talked about binary and ternary relationships, and I said they're mostly binary? This is a ternary, and if you saw the real orbital shift database, it's probably like 6 or 7-ary, because there's a bunch of things tied to it. So an event has to have a location. Where is the person working? What position are they working for? And who's the person working in it? In reality, there's also a type ID, and there's a separate table that's event type. There's also an event status. There's a separate table for the status of the event. All these things are linked together. I simplified it here. So an event has an event ID. That's a surrogate ID. It has a type and a status, which are in reality separate tables. It's also going to have a position ID and employee ID. But that's not how we model it in the ER. We model that by just showing the relationships. An event has one and only one position. It has one and only one location, and it has one and only one employee. You're not going to say someone worked a shift, oh, but 2 people worked that shift. No, those would be separate shifts. And then going the other way, a location has 0 to many events. It has 0, a position has 0 to many events, and an employee has 0 to many events. So you might not have created an event yet for any of these. So that's where it's optional to many. So this is a ternary relationship that in reality is at least a 5-ary, and in reality it's even higher. Now, why would I put type and status in a separate relation and not just include them here? Say type is what I was saying of shift, cover, vacation, unavailable. Status is approved or not approved is what status is. Any guesses? Okay, so you're thinking about it in the right way. So where am I? ER, here we go. If I included a type table here, and in it I put a type ID, which is just would be a auto increment key, and then I put type name, delete that one, and then I make a relationship between these tables, and I say this is a, should be the other way. I haven't used this tool much recently, so I'd have to come up here and I'd change the ends. It would be a 1 here. Where is it? Here. And this would be a mini, and really it would be optional to mini. And this would be, I didn't do it right, would be 1. So an event, no, that's not right. An event has one and only one type. It was right. But a type can be tied to 0 to mini events. So the reason you often model like this is, and is a good point where you might be able to add extra tables if you need it. If I do status here, somewhere in my UI, I'm going to have a drop-down list for type and status. When they create an event, they're going to pick, is this a shift? Is this a cover? Is this unavailable? If I'm getting that from a hard-coded drop-down list in there, and I decide I want to change what I call an event type, maybe cover now is a transfer. I'm going to have to go in my code every single place I hard-coded the word cover, and I'm going to have to change it to transfer. If I do it in my database, I just come in here and I edit type ID 1 was transfer, now it's cover. Or it was cover, now it's transfer. Done. Don't even have to change a line of code because I'm populating that drop-down list from the data that's in this table, from the rows of this table. I'm also giving some relational integrity, referential integrity, which is another thing was not the best on the test. The answers about referential integrity. I'm ensuring that guaranteed the types that are stored here are one of these and not some other one that managed to slip through. We got a sandwich type event. Well, what the hell's that, right? So this guarantees, because of the relation, it's one of these types. Same thing for status. Oh yeah, this should be, no, dotted, solid line is weak. This should be solid, or it should be dashed, not solid. Yep, you're right. So here, this should be, oh, I didn't want that text on there. This should be dashed. Well, no, I just did it with, I think the dash is, to be honest, I don't think they had dashed when I made this. Because I would have done the dashed, I'm pretty sure had it been there. There would have been no reason to do the dots. So this database right here, number of tables that this would produce, every entity becomes a table. 1, 2, 3, 4, 5. Every mini-to-mini relationship will have an extra table. Here's a mini-to-mini. This would be 6 tables right here. Add status, it would be 7. I mean, I think orbital shift, we had 30 or 40 tables in the end by the time I was done with everything. They probably have more now, 3 years later. So I guess the company exists because I got an email yesterday saying my original employee agreement wasn't solid enough and I need to sign a new one backtracking something about intellectual property and that I don't own anything I created, and because the company converted from an LLC to a corporation now. So first contact I've had from my business partner in 2.5 years. So here's this legal document, sign it and give it back. So, did you burn it? How are you doing? Well, no, I mean, we are on non-speaking terms anyway, so that's why I know hi, how are you doing? But I put us on no speaking terms because he doesn't deserve to be spoken to. So yeah. All right. So we feel good about this process for the project. The key to this is making your requirements very, very specific. The requirements to say this would be like 3/4 of a page of bulleted things to get across some of the rules. Like every location is part of a business. That would be a bullet. Every location has different positions. Like you could really come up with a lot of description before. This took me years of understanding before I could just produce something like this and say, yep, this works for scheduling. So that's where you should have the most beef in your write-up, is in those requirements. The more specific you are, the more accurately I can inform you on this, which will mean later in your project, you're not going to hit a situation and say, wait, I wanted my database to support this. If it wasn't in your requirements and you didn't build it here, you're going to have to do some reworking. So were you going to say something?
Well, I'm just asking, if we accidentally goof up the voice feed, that's no big deal, right? At this point, no.
Well,
Goof up one or two.
you'll lose one or two little parts of your points for it.
They're very complicated.
They are complicated. I'm not going to hammer you, but try to be accurate with them. It is complicated. The maximum cardinality is where I'm going to be the pickiest. The outer ones. The inner, whether it's mandatory or not, that's a little iffier, right? Like I just said, even on this, I could argue that these are mandatory, right? I made the decision here that these are mandatory. Why couldn't this be mandatory, right? It's the outer ones that are the important ones. That's the, whether it's a one-to-one relationship or a many-to-many or a one-to-one. Those are the key, because those are what are going to influence the tables we create.
Asking if we got them flip-flopped. If we accidentally split the mini to mini.
I'll point it out, because I'll look at it and I'll probably say, wait, this is wrong. And yeah.
So you can do basically whatever you want in terms of how you want it to be laid out and the type of data that you want in your
Yeah.
table.
Yep. All right.